We're back with another edition of PreCalc here. This is 8.3. This is the last section I had assigned us before all this craziness happened. So we'll work through this and we'll talk about what our plans are for the future and submitting stuff moving forward. I'll post that in the description so you have a nice detailed list of what I want. Let's get going with this. So, inverse of a square matrix. So it does have to be a 1 by 1, 2 by 2, 3 by 3. And if A is some matrix, it's n by n. There exists A inverse, that's the little -1, such that A times A inverse equals the identity of size n, and that's also equal to the inverse of A times A. So, A inverse is called the inverse of A inverse, all that good stuff. How we go through and actually do this to find it, because our first example here says find it, and you're like, well, I maybe understand what it is, but how would we go about finding something like this? So as we've kind of done in the past, if you have some matrix A, you put it next to the identity, and you shift it so that the identity is over here. What you're left with on the right-hand side will be actually A inverse. Not actually all that complicated, but yet again, it's just a lot of arithmetic here. So let's find the inverse of this A here. So we write it out with A on this side and the identity over here, and our goal is to eventually row reduce this left-hand side so that the identity matrix is over there. So our first move, I'm going to say, is let's add these rows together. I liked row 1 where it was at because we had that 1 in the opening diagonal. So I can just rewrite that. When I add these together, we're left with what? 0. We add these, it's 7, 1, 1. Did I write this down wrong? Yeah, I did. It's a -3. I'm like, that shouldn't be a 7. This is a 1. Okay. I like that 1 there. I'm going to use that to manipulate this top part up here. So I can say row 1 minus 4 of row 2. So I liked the second row where it was. So we have to manipulate that top one. That's 1, that's 0. This is where it gets a little harder. Row 1 minus 4 of these, so that's a -3, and a -4 goes there. So our answer here is that the inverse of A is that matrix here. And you could go through and test it out, multiplying A and A inverse, seeing that they will result in the identity. I'll do it for one of the examples, but it does work out for both. So there's our A, our A inverse. Multiplying these together, remember, it's you take this and you kind of spin it. So that does get us a 1 going down. Those are opposites, that's a 0. Here, those are opposites. Notice you get a -4 plus 4. And then the bottom one, we get 4 minus 3. So that checks out just nice. Okay. So let's do some examples with maybe some bigger 3 by 3s now instead. So if I'm looking for the inverse of A here, we put down the identity matrix over here. And yet again, like in that first one there, so I want to take row 2 and subtract row 1. Since I liked row 1, my first move is I'm just going to rewrite all of row 1 exactly as it is. Now we're doing the subtraction, so that's going to get us 0, 1, -1, -1, 1, 0. take your time in going through these, making sure you're getting the right plus or minuses. That can be the confusion in here. We're literally just taking row 2, subtracting row 1. I want to get rid of the 6, so row 3 I'm adjusting, and I'm going to subtract 6 row 1s from it because I'm using that row 1 kind of as my tool to eliminate the things below it to give us zeros here, which is what we end up getting. And we should end up here. Really nice first column that we have 1, 0, 0. We then would want to move on to the next column and have this be a 1. Very nicely that it is a 1, so we can use that as a tool to eliminate that -1 and that 4. Those are our thoughts going into this next one. So since I like the middle, I can rewrite that row there. And I just need to change row 1 by adding row 2 to that. And what we're going to get here there we go. And we want to adjust here, so we have our row 3, and I'd like to subtract 4 row 2s from it. Oh, that's always nice. Having that 1 pop up here. So now notice we're kind of making this look like the identity. We go column by column. 1, 0, 0, 0, 1, 0. Now we're looking at this last one. We have the 1 there, and we can use that to eliminate the things above it. So I like that third one. I'll leave that there. And what do I want to do? Just add them. Actually, this is really nice. Row 1 plus row 3. So we add these together. And then row 2 plus row 3. And so we have that the inverse here and I think I did that right. Let me check. Oh, this is a 3. I can read my own handwriting. Great. And we have the inverse of A completed there. Let's do one more example where something a little strange happens. So if we want to find the inverse, same procedure. We write out A, and then we put the identity over here. And let's eliminate the things below. The 1's great. We can subtract it to get a 0 here and add it to get a 0 there. So we want to change row 2 by subtracting 3 of row 1. That's going to get us 0, -7, 2, -3, 1, 0. Next, we'd like to change row 3. So we're going to add 2 row 1s to that. 0, 7, -2, 2, 0, 1. And this is the first time so far here that we've seen this doesn't come up a 1 nicely for us. So you may be thinking, well, we want to divide by 7 and do some stuff here, but I'm going to take a kind of step back and look at the bigger picture here with -7, 2 here, and then 7, -2. And think, well, we can do a lot of elimination there if we just add those together. So let's say we want to change row 3. So I'm going to rewrite the first 2 rows here. And when I add these together, we all of a sudden are left with this. And you should definitely have some red flags going up with this line right here. How can we have a bunch of zeros on this side equaling something that's on this side? That is definitely not possible. Think you can start adding these above and it starts manipulating all of these things when you're not changing anything over here, but you're changing what they're equal to over here. That is definitely a contradiction. So, if you see a bunch of zeros on the left equals something on the right, all of a sudden that's saying that there is no inverse. To A. It's just not a thing. And you may be thinking, well, how can you not have an inverse to something? Think of what's the multiplicative inverse of 0. Oh, we can't make it 1 over 0? That's not a thing? Right. So there are some things where we can't actually have inverses to them. And same thing in matrix world. And I think we have 2 pages left. We're getting there. There's a really nice way to find the inverse of 2 by 2 matrices. Specifically, if you have some matrix A, and we'll just call it A, B, C, D, going across, then A is invertible if and only if AD minus BC, so AD is this first diagonal, BC is the second one, does not equal 0. If that doesn't equal 0, then the inverse of A is simply put as this, 1 over AD minus BC, and then the matrix here. Let's try some examples of that right here. So we have this matrix A. Let's do 1 over AD, that's 3 times 2, that's 6, minus B times C, that's a negative times a negative, so that's a positive, so that's a 2. And then we want to kind of manipulate all of these terms over here. So this 2 and 3 flip-flop, and these flip-flop and become negative. Okay, but this constant out front, remember, is 1/4. So our real answer here is 1/2, 1/4, 1/2, 3/4. So that is the inverse to this matrix. And it's a lot quicker than going through and doing that big old complicated process. So for 2 by 2s, this is really nice. Let's look at this one over here. We have 1 over 3 times 2 is 6, negative 6 times negative 1. And you should be saying, uh-oh, because we have 6 minus 6, which is 0, which is giving us a 1 over 0, which, as we just talked about before, we can't have. So this is one of the reasons why these matrices are invertible, because we do run into this 1 over 0 situation. So there's no inverse here. So this is a really, really nice shortcut for 2 by 2 matrices. And then let's talk about one last thing here with inverses and how they come up. So you could be given a system of equations with a unique solution that you're trying to find. And we could define A as an invertible matrix in a system of linear equations represented by this. A times x equals B, and it has a unique solution where x is A inverse times B. Note that this is not, x does not equal B times A inverse. Because how we actually get to this designated spot is if we're starting here and we would like to remove the A. Remember, which side you multiply matrices by is important. So we're multiplying by the left side here and the left side here, meaning that x equals A inverse B. So that is how you could solve these systems. So let's be given an inverse matrix to solve. Specifically, let's say we have this one here. X plus 4y equals 9, negative x minus 3y equals negative 7. So we could break this up and say A is this, 1, 4, negative 1, negative 3. The x, I've wrote as x1, x2. It doesn't matter if you write xy. I couldn't make up my mind, as you can see. And then 9, negative 7 as our b. And we're trying to solve this system. So the first thing we need to find is A inverse. So I need to take this matrix and find its inverse. So let's do our little trick here. 1 over, this is negative 3. This one is going to be plus 4, which just makes it 1, which is really, really nice. These have to flip-flop, negative 3, 1. and then these flip-flop and negate. So I believe that is going to be what we're looking for here. Am I right in that, or did I mess that up? I gotta look back at my last sheet. This one I didn't do all out. Oh no, sorry, these don't actually flip-flop. Did I mess it up on the other one? I might have. I definitely did. Sorry. These stay the same, so this is a -4, and this just becomes a regular 1. I messed up over here. These don't flip-flop. They just negate. So this is 2, that's 1. My bad. Sorry if you had some confusion there. So yeah, this is -3, -4, 1, and 1. And it's all being multiplied by 1 over 1. So our A inverse is simply put as -3, -4, 1, 1. Sorry about the mistake on the last one. I should double check that as well. Okay, once we have that inverse, we know that our answer here, x, should equal A inverse times B. And so we have to do this multiplication through. Remember, these are spinning, so we have -27 plus 28 here. And here it's going to be 9 minus 7, so our answer is 1, 2. And you can check that in the matrix up here. Another kind of check to make you believe that this is how we actually find the inverses, and I'm not making that up, is this is the very first little 2x2 we did back in like minute 2 or 3 of the video. Great. Okay, in the descriptions, I'll post what I want you guys to send to me because I need to start collecting work since we're not going back to school. I need to start updating School Tool with grades and all that good stuff. Okay, hope everyone is safe and healthy, and I hope to get an email from everyone soon. Bye, guys.